When we work with circle equations, the equation itself actually comes from the Pythagorean theorem. That's why you see this squared portion, always a plus sign here, another squared portion equals finally the radius squared. So some reminders on this. The x and the y, that's going to shift based on your center value. So for instance, for example 1, if the center is the origin, there's no shift taking place. So you can just say x squared plus y squared. And I drew a little sketch. I want my circle to pass through the point -4, 0. So my radius, because I can go horizontally here, is 4. So I just squared that, and there's my 16. The other strategy you could always use, especially if maybe your point was diagonal, so the radius is a little bit tougher to find, you could plug the point that it has to go through. So once you have your center in place, your x squared plus your y squared, just leave r squared as my radius. And I just plugged in the -4 for x. It has to go through that, has to go through 0. Remember to square that negative, so it becomes positive, and there's my radius squared as 16. For the next equation, they gave you the diameter, so it has specific endpoints. The key to this is find the center first, then find the radius. So I connected those endpoints. I drew a little circle just to have that visual. I looked at slope. I went down 3/4, down 3/4. So my center, or the midpoint, is definitely at 0, -1. And because you're already on a graph, I found it easier to find my radius squared with the Pythagorean theorem itself. So that's where I chose 3 and 4 for the dimension of this radius. And I got 25. And then plugging into my circle equation, I have x squared, because the x center value was 0. Y plus 1, it's always opposite. That quantity squared equals 25. So now going to a little bit more algebra-based problem. This will be good going into Algebra 2 next year. We're going to take this equation and we're going to make it our standard form of our circle. So I always suggest grouping all the x stuff and y stuff. That's not very mathematical, but all the x terms and the y terms together. And then anything constant, I put to the other side. So I subtracted over the 29. So that's how I got 71 here. Now, if you have an x squared and an x term, or a y squared and a y term, you have to complete the square. So I try to give you a couple of visuals on that, and I'll walk you through that, but you could always investigate or Google completing the square, and it will walk you through that too. So when I complete the square, I like to keep things balanced, and I throw a box on both sides of the equation. So the issue is, what do you put into that box? So when you complete the square, you technically want to figure out this constant value. So just this number. It depends on the b value though. So the number in front of just the linear term, the number in front of the x. So I take that number, which is 4, so that b value, I put 4. I divide it by 2, because I'm trying to find 2 values. And I want those values to multiply with themselves, so that's why I square it. So half of 4 is 2, 2 squared is 4. So I put that here. If I add 4 to one side of my equation, I keep it balanced, add 4 to the other side. For the y information, I look at the -10. Technically, you can ignore the negative, because when you square it, it's going to become positive. So I just took the positive 10, divided it by 2, which was 5. So I have 2 5s, and I squared it, 25. Now the reason why you complete the square is, then you have a squared factor term. So again, reminders on factoring, you're looking for 2 numbers that multiply to 4, but add to 4. So 2 times 2. Or you could think of it, it's just going to be this number prior to squaring. 2 numbers that multiply to positive 25 add to -10. So they're both going to be negative to multiply to positive, but both negative to add to a negative. So 5 times 5 is 10, 5 times 5 is 25, 5 plus 5 is 10, both negative. You don't have to put this step. I think it's just nice to know where it comes from though. So then your final circle equation would be x plus 2 squared, because that was repeated, plus y minus 5 squared equals 100. And if you're asked for the center, radius, or diameter, the center would be the opposite, so -2, 5. This is my radius squared, so I took the square root of it for 10. And if the radius is 10, I double that, and your diameter would be 20. So just did a couple more of these on the back to kind of get you back into the rhythm of going through these types of problems. So with this one, it actually has less terms. Be careful there. I have an x squared. I have nothing else with that. You have one x squared. You do not need to complete the square. So I left that alone. I know the center is going to be 0 for that portion. However, I have two y terms. I have a y squared and negative 8y. So I took the 8. You could even take the negative 8. I just ignore the negative for a second here. Cut that in half. So 4. 4 squared is 16. So I made sure I've added 16 to both sides of my equation. That's the number one mistake students make, is they forget to do that. And then I could have done my factoring step, or I could have said, okay, well, I cut the 8 in half, so I have 4 twice. 4 squared is 16, and make it negative. And taking things out of the equation, the center would be 0, positive 4. And then the radius, well, if the radius squared is 72, I do the square root of 72. It's not a perfect square. So I find the largest perfect square that divides into it. It happens to be 36, 2 times. Square root of 36 is 6 square root 2. In terms of the diameter, I want to double that. So I multiplied it by 2. When you multiply, you're not going to multiply inside of the radical, okay, inside of the square root symbol. You're just going to multiply the outside pieces. So 2 times 6 is 12. If you're ever given a problem where there's a number other than 1 in front of the x squared or the y squared, you need to divide it out. You cannot use this completing the square strategy on any quadratic that has a coefficient other than 1. So I divided everything by 2. The cool thing with circles is whatever number is in front of the x squared, the same one will be in front of the y squared every single time there's a circle. So I divided out. I had everything kind of lined up. I had my x terms, my y terms, and my constant. I completed the square. It was the same number both times. 2 divided by 1 is 1. I squared the 1 here. So there's my 1 again. 1 on both sides. Took the 2 here. Divided by 2 is 1. 1 squared again is 1. Added that to both sides. And then I just have to be careful with the signs. So positive 1 times positive 1 is positive 1. Positive 1 plus positive 1 is 2. Whereas this one required a negative 1 to get you to that multiplication of 1, but the addition of negative 2. Took my center out. It was opposite. So negative 1, 1. The radius is the square root of 9, 3. And the diameter is twice that, 6. So in the last example, I want to know which point also lies on the circle. So I would say do a little bit of a plug and chug here. So write your circle equation, plug in the values, see which one works. You can also put this in your calculator and kind of explore that way. So the first thing I did is I need to have an equation to help me. So the circle whose center is the origin, so 0, 0, it passes through the point negative 5, 12. You could just, you know it's x squared plus y squared equals radius squared. So you could just plug in the 5, square that, the 12, square that, you know your radius squared. That's just your Pythagorean theorem. You could graph it if you want another visual. So then I went ahead and wrote my circle equation, x squared plus y squared equals 169. And I just started plugging in points. So I plugged in 10 for x, 3 for y. I went through my equation. Does it equal 169? No, it's 109. No way can that be on my circle. Kept doing that strategy until I went through number 3. I know that looks weird, but use your calculator to help you. So what happens is, number 3 is down here. 11 squared is 121. 2 squared of 12. If you went backwards, that's square root of 48. If you squared that, that's positive 48, or you can put that in your calculator, and there's 169. So just like you've done with any kind of equation in the past, if you want to know if something works on the circle, on the line, on the parabola, take the equation and plug in. So I think you've seen my battery is about to die, so I'm going to cut you off there, and I'll talk to you soon.